I'm going to talk about just looking at the front, the first five, which is tonight's homework. When I say tonight, I mean Monday, August the 30th. Um, but one, two, three, and five are not really problems. So I was thinking, well, how can I do a help video on those? A silent help video. I really can't do it because they're more of discussion. So instead, I'm just going to, on those four, I'm going to just do it all right here just to help you in case you need it. All right, because a lot of it's just, are you doing it right? Number one's asked, what is the most important word in physics and why is it so important? And we talked about this like on day one or day two, and that is relationships, the idea of relationship. And why it's so important is you can't say force. I mean, force is important, but that's not the overriding importance, or acceleration, or energy, even energy. You can't say that's the most important word because it limits you. But one thing we do study every day is relationships. And if we're doing kinematics, it's position versus time, or it could be velocity versus time. Okay. So that's the idea there, just something along those lines. You don't have to say word for word, but Number two says briefly describe at least four different types of movement you are undergoing sitting still in your chair. If you go back and look at your notes and a lot of this is go back and look, or maybe they're not in your notes, but they're in the screenshots. So go back and check screenshots from about the second, third, fourth day, class 2, 3, 4, somewhere in there. But you probably remember it. I mean, you're sitting still. I'm sitting still in this chair, but actually, relative to the Earth, I'm rotating at about 780, 850 actually, Oklahoma miles an hour. If I was on the equator, it'd be 1,000 because it's a bigger radius. That kind of thing. We talked about the Earth around the sun. You know what I'm saying. So I'm not going to say all those because you should be able to get at least four of them. Number three. Or with all the constant motion we are undergoing just sitting in your chair in Oklahoma, what's the physics definition of motionless? And remember, we went out in the hall today for sixth hour and Friday for second and third, where we kind of played the motionless dance, where you have to partner, you have two or three partners, and you have to basically mirror what they do. So, like Brody, today I had him, if he stepped forward, I had to step back. If he stepped to the left, I had to step to the left, so that if you look at it, if we were like two dots and you only looked at relative to each other, those two dots can't be moving. Like you can be going down the highway at 75 miles an hour and not be moving if there's a car in the other lane going 75 miles an hour right with you. Relative to that car, you're not moving. It seems silly, but if you can't really, these are the thoughts of Newton. If you finally have to agree that you're always moving in our universe, you have to localize the reference point. And so the reference point sometimes is your origin, sometimes just a reference point. And your origin, by the way, is not necessarily where you start. There's an origin for a group, like in the graphs we're doing. Like sometimes you start 10 meters from the origin. So your starting point is not necessarily the origin. But you want to relate everything to a origin that you pick. Okay? Say this point is where I'm relating everything to. Okay. And if that point has to be moving at the same velocity as you, then and that velocity takes into account position, changing of position, and the direction. It's not just that. Like for instance, you can't orbit somebody and say that you're not moving relative to them. The distance between you and that person isn't changing, but the orientation is. And so a vector requires both. Got to talk about vectors tomorrow, but a vector requires both, distance and orientation. Number four. I'll do a silent help video on that here later on today, and that'll be up by, 6, maybe tonight. Hopefully, if not, it'll be 6:37. Number five, It says list the 4 fundamental forces in order of strongest to weakest. We have a number of tables on those. I don't need to do that again. You go ahead and list those. And then what big advantage do 2 of them have over the other 2? My hint there is think about range. I mean, yeah, gravity's super weak. Electromagnetics isn't weak, but it kind of has the best of both worlds. E&M does. Someone asked, it wasn't this year, but they asked a couple years ago. So, just speaking of 4 fundamental forces, so you have the strong nuclear and electromagnetic. Well, they all, and I showed you this today. Within the first billionth or really trillionth of a second, they had split up in the universe. So that electromagnetics is still together. I do this because it's kind of like the way they are. They're intertwined. They're like sewn together. I'll show you a good animation on that eventually. But one question that kid asked, well, might they split up? Might electricity and magnetism split up? And the answer is no, because the way electromagnetics works is a little bit of electricity has to be there to make the magnetism. Magnetism has to be there to make the electricity, and those would not have split up. And if they had split up for some crazy, I don't know what the world that would be, it would have happened within the first second of the universe. 5B says, what's the big event? Okay, 5, we talked about that. 5C says, what is it about the weakest one that we haven't discovered yet? Now, I'm going to give that away, but if you look at the table, I'll say this, it has to do with the carriers, okay? And it wasn't our discussion. And I think I wrote about it in the captions, so I'll leave that one to you. Okay, so that's good enough for this one, 7 minutes long, but that took care of 4 of the 5. And then look for the Silent Help video to go into the playlist for test 1A. All right.